All right, welcome back, Bobcaps. Let's take a look. Is this function going to be growing or decaying? Well, as you go from left to right, it is going up, so this is what we would call growth. All right, and we'll go ahead and label these points. We have 0, 1, we have 1, 2, we have 2, 4, and we have 3, 8. Our y-intercept, that's our 0, 1. And our common multiplier is, how are we getting to each number here? Well, we are doubling each time, right? Because 1, and if I multiply times 2, if I take 2 and I multiply, it gives me 4. If I take 4 and I multiply it, it gives me 8. So my multiplier is times 2. So the function is going to be f of x, which is a function of x. My y-intercept rate begins at 1, and it is doubling each time. So if I type this in, I should get this same function, equation, so on. So I have f of x equals 1 and then we're going to go shift 6x. Okay, and then we're going to turn this to a table, and I'm going to focus on the table. So it brings it and narrows these in. Right, my y-intercept's 1, that's sitting here. I have 1, 2, which is part of my table. I have 2, 4. If I wanted to include the next value, there's 3, 8. There it is right there. So all my values would start growing on the table. What is my asymptote? Asymptote is like a fence that you never actually cross. What do you mean? I'm saying, like, I'm going to have a line that's sitting here at y equals 0. And this line, okay, is really a dash line. I'm going to make it a dash line. What are you saying? Here's what we're saying. Let's make this a different color. Oh, purple looks good. Let's make this purple too. Yeah, that's fine. Leave that there. All right, so here's how this goes. If I focus back in on here, right, I made this line right here, this orange line. And if I go across to this orange line, it looks like that the orange line and the purple line are going to touch. But here's the thing. They never actually touch. It's like a fence that you get really close to and you never actually touch. We call this an asymptote. Okay, it will never, ever actually touch the orange line. It just gets really, really close to the orange line. Okay, it'll keep getting closer and closer to the orange line, but it will never pass the orange line. So that orange line is our asymptote, and the equation for our asymptote is y equals 0. Our domain, well, our line, if we read it, it goes left and right forever, okay? It goes left and right forever. It goes left this way, and it goes right. As I go this direction, it's going up and to the right, but it's still going right, okay? So my domain is going to be all real numbers. What's really nice is that every single time, if it is a function and there are no restrictions, it will always be all real numbers. Our range, kind of nice. Focus on our asymptote. It's very similar to our asymptote. It's going to be y and 0, but it's strictly greater than. All the values that are bigger than 0. Okay, so let's take a look at the next problem. I got a new equation, and my new equation is, given this function, what is the domain and the range? Okay, so I have g of x equals -7 4 to the power of x. So shift 6, or you can also hit this right here. It will take you to the power of. Okay, so I focus in on my points, whatever. What do you notice? Well, this line is still going to go left forever, okay? And it's also going to go right forever, okay? It'll keep going right forever. So my domain is still the same as it was on the other problem. So it's still all real numbers. However, this time, all of my y values are strictly less than 0. So I still have my asymptote, even on this problem, y equals 0. Okay? And that would still be sitting right here. Like if I scroll in and zoom in, it's still not going to get to that line. So all my values are strictly less than. They're less than 0. Okay, let's take a look at the next couple of problems. We have another problem here. Is this growing or decaying? Well, you can tell that the line is going down as we go left to right. So this is what we would call decay. Right, and we can write down our y-intercept. That is 0, 9. I'm going to also put him in this table. I have 1, 3. And I have 2, 1, and that's all I have, and that's fine. So, how do I get from 9 to 3 to 1? Well, this might be a little bit harder to see, so what we could do, and this is always an option, is you take the bottom number, the 1, and divide it by the number above it, which is 3. That's real poopy. 1/3. Okay. Let me try this again. What if I take 3 and divide it by 9? 3 divided 9. Also 1/3. So here's what we're saying. If I want to go from this to that, I'm going to multiply by 1/3. If I want to go from 3 to +1, I'm multiplying by 1/3. What did I do? I just took the bottom number and divided the number above it. The bottom number divided above it. Okay, so my common multiplier is times 1/3. Okay, so what is my function? Well, my function is the equation. Put the two things together. We have our function of x, which is equal to my y-intercept is where it starts, and it's being multiplied by 1/3 each time. And so if I type this in, I should get that same set of points, same looking line. F of x equals 9 parentheses 1 divided by 3, arrow over, to the power of x. And I'm going to hit home. There's my graph. There's 0, 9. If I turn it to a table, it will produce more of those points. If I hit the magnifying glass, it'll focus in on the points that are on the table. Is my asymptote still at y equals 0? Yes, it is. It's always there. It doesn't change. It will always be at 0 for us in Algebra 1. Okay, so my asymptote, y equals 0. And my domain is going to go left and right forever. And my range is strictly all the values that are greater than 0. So greater than 0. Not equal to because of the asymptote. It never touches 0. None of these y values will ever be 0. All of them will strictly be bigger than 0. All right, in our last problem, we want to know what the domain and range is of this. Well, this is a part of a graph. We don't even have the full thing. Okay, so the domain, I'm going to actually take this and say, okay, well, it's not all real numbers because it doesn't go left forever. It doesn't go right forever. It only goes left so far, and then it goes right forever. Okay, so what's happening? Well, maybe we'll get us a couple of highlighters out for this. So, our domain. All right, we look at our x values. It's our domain. Okay, and our domain, this is saying it starts at -2 and then all of the x values are bigger than that, and then it goes to infinity. That would be the most right. It's not 1, it's not 2. But again, we don't write it like this in Algebra 1, these little infinity signs. Okay? So we're going to actually rewrite this. The formal way to write it is that the x comes first, and then my sign flips to face towards x, and then this is going to say -2. So all of the x values that are bigger than -2, equal to -2, and bigger than. All right, and my range. What is my range? Well, I'm going to do the same thing, except now I'm going to look at the y values. And again, we start from the lowest. What is the lowest that the line goes? The lowest that the line goes looks to be about, if I were to take this back over here, that looks to be about 4.5. And then I would say it goes up forever. But again, we don't write it like this with Algebra 1, with the little infinity sign, or that symbol. So when I rewrite this, it's going to read y goes first, 4.5 goes last, and my sign's going to open towards y. So this reads that y, all the values are bigger than or equal to that 4.5. It starts at 4.5 and it goes up forever. All right, Bobcats, thanks for watching, and we'll catch you next time. We'll see you later. Have a good one. Word.